Hello everyone, I welcome you all to a new lecture of Chapter 10 Circle. Myself Palak Agrawal and I'll be teaching you this chapter thoroughly. So let's start and see what we have to learn today. So the first is circle and its related term. The collection of all points in a plane which are at a fixed distance from a fixed point is known as circle. And this fixed point is called center and the distance which is fixed is called radius of the circle. Okay, so here the fixed point is O and OP is the fixed radius where every point is located. And when we try to join all the points, we get a figure known as circle. Correct? Okay, now the line joining the center to the boundary of the circle or any point on the circle is known as radius of the circle. Radius is used in two senses, in the sense of line segment and also in the sense of its length. Correct? Okay. A circle divides the plane on which it lies into three parts: interior, exterior, and boundary. Circle. Correct? So, interior are those which are within the circle. Correct? Outside points are those which are beyond the circle scope. And on the circle means that the point which lies on the boundary. Correct? So, the three parts are shown to you clearly with the diagram. Okay, next. If we take 2 points on a circle, then the line segment obtained by joining the 2 points or the points on the boundaries is known as chord of the circle. And this chord which passes through the center is the longest chord of the circle, which is also called diameter of the circle. Diameter is always equal to 2 radius. Since it's passed through the center and both the sides, the distance is equal, which should be equal to 2r. Okay, so I'm giving you certain additional informations too at the time of discussion. Okay, yeah. A diameter is the longest chord and all diameters have the same length, which is equal to 2 times the radius. The word diameter is in two senses. It's a line segment and also as its length. The length of the complete circle is called its circumference. Circumference is the length of the boundary. Okay, the curved part. Correct. Now, the piece of a circle between 2 points is called an arc. And with the portion which is lesser than the other is major and minor arc. Okay, shorter one would be minor arc and longer one would be major arc. When 2 points are ends of a diameter, then both the arc, which is called as semicircle, and they would be equal because diameter divides the circle into two equal halves. Okay, so if diameter is drawn and that is the line segment, then the arc would be of equal size and also known as semicircle. Okay, the region between the chord and either of its arc is called segment of the circular region, or simply segment of the circle. So minor segment and major segment. The region covered by the minor portion, or we can say that the minor arc is called minor segment and other one is called major segment. Okay. The region between the arc and the radii joining the center to the ends of a arc is called sector. And similarly, the portion which is shorter than the other or the minor arc corresponds to minor sector segment or major corresponds to major segment. Okay, so we have learned about minor major arc, minor major segment and minor major, what was that? Segment. Okay, correct. Now, the next we would discuss about angle subtended by a chord at a point. Now, we already know what is chord. Okay, consider a line segment called PQ and a point R not on the line containing PQ. If we join PR and QR, we get an angle PRQ and it's called angle subtended by line segment PQ at point R. Okay, so the line segment PQ is already drawn to you and a point R is taken. Now we just need to meet the angle PRQ. So PRQ would be the angle subtended by line segment PQ at point R. Okay, so this way this angle is called. So angle subtended by a chord. Now we have learned what is the word meaning subtended. Okay, so we'll implement it in circles. Equal chords of a circle subtend equal angle at the center. So similarly, when we take a point R, here the point is center. And when a chord suspend an angle, that means it creates an angle with the center, then two chords of equal length would subtend equal angles. Okay, so here AB is equal to CD, so angle AOB would also be equal to angle COB. Now how to prove that? Just draw the two triangles, prove that the two triangles are congruent by triple S condition. Since it's already given AB equals to CD and AO, BO, CO and DO are radius and radius of a circle, all the points equal. So they are congruent, the triangles are congruent by triple S. And since they are congruent, the angle would be equal by CPC. Okay, congruency part of congruent triangles. If angles obtained by the chord of a circle at the center are equal, then the chords are equal. This is just a converse of 10.1. Okay, so this can be proved in the same way. Prove that the triangles are congruent, and if triangles are congruent, then AB equals to CD by CB. Okay. Now, the third thing which we would discuss today is perpendicular from the center of a chord. Okay, so I am again repeating what is chord. Chord is the line segment joining the 2 points on the circle, correct? On the circle means boundary of the circle. Now, draw a line segment, draw a circle on tracing paper and O with center and chord AB is drawn on the circle. Fold the paper along the line to O so that the portion chord falls on other. Let the crease cut AB at the point M. And we know that angle OMA and OMB will be 90 degrees because we have folded it on equal parts. Now, OM is perpendicular to AB, which leads to, we notice that AM is equal to MB, means perpendicular from the center to the chord divides the chord or bisects the chord. Correct? So, the perpendicular from the center of the chord bisects the chord. So, we have already proved using an activity. Now, we can also prove it by using the angle congruency condition. We just need to prove that both the triangles are congruent to each other, and we can do that by RHS. Since hypotenuse is radius and they have a common side OM and the one angle is 90 degrees. So other side would be equal by CPCP, which is AM would be equal to MB, and hence the chord is bisect. So the line drawn to the center of the circle bisects a chord is perpendicular to the chord. Just the opposite or converse of 10.3. If it bisects the chord, then definitely it's perpendicular from the center of the circle. Okay, so we'll wrap up here today, and we have learned 3 concepts. I hope you remember them all. And from the next part, we would be starting with circle through 3 points. Thank you so much for attending my lecture.